part of the lesson that we didn't finish on Thursday because it wasn't on Friday's quiz was limits 3, talking about limits of rational functions, otherwise known as limits at positive or negative infinity, also sometimes called end behavior limits. So if I've got a ratio or fraction of two polynomials, then I can figure out what the limit is at the ends of the function by looking at certain characteristics of the exponents. So I'm going to ask you to pause here, and then you have some blanks on this page to fill in. And I would do that and then wait for me to explain what these different characteristics are. So you have to memorize what these different relationships are. And remember that you do have access to a note card for your test, which is Tuesday. So when we look at the degree of each polynomial, numerator and denominator, there's a relationship between the two. In the first case, where it says if n is less than m, that is saying that the degree of the polynomial in the numerator is less than the degree of the polynomial in the denominator. When that happens, we say there's a horizontal asymptote. That asymptote is always going to be 0. And another way we talk about this type of relationship of the exponents is we say that the function is bottom heavy. So when we say the horizontal asymptote is 0, we are saying that the limit, the answer to the limit question, as x approaches infinity or as x approaches negative infinity, is going to be 0. When we look at the degree of the numerator and denominator and they're the same, then there is a horizontal asymptote, but the answer to the limit, or that horizontal asymptote, is going to be a ratio of the leading coefficients. So if each of my polynomials, numerator and denominator, are in standard form is decreasing exponents, then when I'm talking about the ratio of the leading coefficients, if I'm looking back here when it's talking about the equation of f of x divided by g of x, these numbers here in the very front of the equation, if the terms are in decreasing exponent order, that's the ratio. It's a over b. Last scenario is when the exponent degree on the numerator is greater than the exponent in the denominator. When that happens, there is no horizontal asymptote. In fact, there's a slant asymptote, which is basically a diagonal asymptote. And when you've got a diagonal asymptote, if you think about it, that end behavior is not going to have any answer. The answer is going to be infinity, right? If you follow along your slant asymptote until it goes all the way to positive infinity, then likely your end behavior is going to be positive infinity. In that case where the top degree is higher than the bottom degree, we call that top heavy, and the answer is always going to be infinity or DNA. So let's look at these examples before you do your turn. In number 4, one thing we're always looking for is down here We're always approaching infinity, approaching infinity. When we're approaching infinity, that is our end behavior asymptotes. In the first one, I've got 4n to the first power, because there is no exponent there. When there's no exponent, it's 1. And that is divided by n, and I don't see the power either there. So that's 1. Remember, when the ratio, or not the ratio so much as, when the degree of the numerator is the same as the degree as the denominator, that's when we do a ratio of the leading coefficients. There is a 4 in front of the n in the numerator. There is no number in front of the n in the denominator, so that's 4 over 1. The limit answer is going to be 4. N to the first, that means ratio of the leading coefficients. Number 5, on the top, the exponent is 1. The exponent in the denominator is 2. That's going to be bottom heavy. When our ratio, I'm sorry, I keep saying ratio. When our exponent in the numerator is less than the exponent in the denominator, that's a bottom heavy function. Bottom heavy functions, the answer to the limit question is always 0. Number 6, the exponent in the numerator is 2. The exponent in the denominator is, I can't really read it, looks like 1. That is a top-heavy function, which produces a slant asymptote. And when I have a slant asymptote, there is no answer. The answer is either infinity or does not exist. Last one, the limit as n approaches infinity. Our first term is n squared. In the numerator, it's n squared. In the denominator, those exponents are the same. I don't see a leading coefficient in front of the numerator, so that's 1. I don't see a leading coefficient in the denominator, that's also 1. The ratio of 1 to 1 is 1, so the answer to the limit question is 1. Now you can stop the video and try your turns and check your answers in the class notes.